Hi everybody, welcome back to the TETRIX RoboBench video series. This is Tim and we are ready for activity number 12 of the TETRIX PRIZM programming guide. Now we are going to build on what we did in the previous activity where we drove to a line and stopped using the line finder sensor. So we're going to actually expand on that activity, and this activity is about following a line. So this is going to use a lot of things we've already done, so that's a good thing. This is building on what we already know. So let's gather our material together. We need to make sure that we have our PRIZM TaskBot with the PRIZM mounted up, charged battery. We've got our sensor pods mounted on the front so our robot can be smart. We've got our USB cable to be able to connect the computer with the TaskBot. We've got a computer and we've got our software ready to go. So let's go ahead and let's open up our software. And in our Arduino software, we're going to go to the File option, go to Examples. We're going to go down to our TETRIX PRIZM library, and we are going to launch the one that says TaskBot Activity 12, Follow a Line. That's going to go ahead and open up here for us. And when it does, I'm going to open and expand my window here so I can see the whole thing. And let's take a quick look at this sketch, because again, we can read our comments like we have in all of them and get a good feel for what the program is intended to do. And this, as our comments say, is going to allow our TaskBot to follow the line using the line finder sensor on sensor port 3. So if we look down into our setup, we've got the same set motor invert. We want our motors to work together. And looking down into our main loop, this is actually a pretty simple program based similar to the one that we used the if statements, the two if statements in introducing the line finder program back in our getting started activities. The only difference that we've got here in our if statements, when we actually read the line sensor on digital port 3, we compare it to the output value, and then in addition to setting the motor powers, we're also adding a second command with that actually uses the set ready LED light on the PRIZM. So the idea is, or expectation is, that when the robot is following the line, and line following is basically not really following a line, it's following the edge of the line. So the line finder is actually looking for that edge of line between the light and the dark. And as it reacts to the dark, it turns back toward the light. And as it reacts to the light, it turns back toward the dark. So in that series of turns, it will actually waddle or move down the line and follow the edge of that line. So that's what line finder behavior is all about. But as the sensor is moving over that, the LED will also show the condition of the line finder sensor. So as it's over the white background, it will give one condition. As over the black line, it will give another. So that's what we should be able to do. So let's go ahead and let's upload our code. We're going to make our connection to our computer. We're going to make our connection to our PRIZM. We're going to power on our PRIZM, waiting for the blue light and our solid green light there. We're going to go into our actual code. We're going to verify, make sure that our code is correct. There's no error messages. Then we're going to go over to the upload, press that. We're going to look for our data lights. We should be getting those. Oh, and I've got a little bit of an error message. I forgot to check my port. So I'm going to go back up here to my tools, make sure that I've got my device selected. And I'm going to try that one more time. I'm going to hit my upload. Here we go. This time it's actually working. I should get some data lights. It is done. I am ready to, I've got my solid green light here. I'm ready to unplug my USB cable. I'm ready to set my robot down on the floor. I will need a white contrasting background with a line for it to follow. So I've got that set up. So I'm going to set it down on the floor, and then we're going to try and execute it. Let's do that now. All right, now we're back, and we can talk about a little bit of whether or not the behavior of the robot really matched our expectations. Were we able to set the robot down? Were we able to actually press the start button and it did follow the line? If it didn't, there are some things that we can do in our troubleshooting for actually to see if there's something going on with the line finder sensor. So we can check and make sure, obviously, first that we've got a good connection in the right port. The next thing that we can do is we can check the LED light on the sensor. I'm going to hold this up there and show you that as I move that over that surface, closer to the surface, I should get a red LED as it reflects off the light surface. As I back up and it loses the reflection, this would be like if it's over the black line, I should actually lose the LED. So when you set that on your surface that you're trying to follow the line, if you move the sensor over the white, you should get the red LED. If you move it manually over the black line, you should get the LED go out. So that's some troubleshooting tips. There is an adjustment on the sensor that you can actually tweak to make sure that the sensor is reading correctly at the right height. I would recommend, again, that if you haven't already downloaded the Programmer's Guide, the digital copy of the Programmer's Guide, do that. There are some additional troubleshooting tips available in that. So if once we got our sensor working, if it didn't work the first time, try that again and make sure that our program actually did what we wanted it to do. Again, the program in what we were looking for in the sketch should have been very familiar with what we already looked for in several of our other activities. Getting started, introducing to the line finder sensor, the two if statements, flashing the LED, the very first activity we did. All of those we just are putting together now in some of these activities, things that we've already worked with, bringing them together, making a more cohesive, different use of the behaviors we're already familiar with. So I hope that's makes sense to you guys. Let's go ahead and talk about some of the real-world connections, because obviously when we want to make sure that we draw those, there are a lot of exciting things going out there where robots actually use sensors to help define the path. For instance, mail delivery robots, things like that are used in all kinds of different things where we know what the path might be, and we have the robot follow that path to be able to move to a specific location. There's warehouses where, depending on what order is made, it might follow a different color line path. So it can make smart decisions based on where it has to deliver things. So line following or using that type of defined path is very common among robotics in use in the real world. Let's talk about STEM extensions that potentially are available for us to talk about. There's light reflection, absorption, angle of incidence, reflection. There's technology, there's threshold values, black and white analog, acting as an on and off as a digital signal. Engineering, what's it take to actually build a robot that will actually implement a line following behavior? And then from the math standpoint, we can talk about logic and what it means for a logic statement in order to be able to apply that to problem solving and the programming aspect. So where do you take it from there? Well, when you start the hacking the code activity and beginning to expand on this, we again would encourage you to create that sketch from scratch, exploring and building on that syntax comfort level and being able to write sketches on your own. Remember, there are code examples in the back. If you have trouble that you need to do copy and paste from, you can avail yourself of that. But challenge yourself to maybe make your robot follow the other side of the line. Change the code up a little bit, or maybe make it follow the line as fast as you can without losing the line. There's several things that as you begin to explore this activity and see how the robot behaves, that you can change your code up and challenge yourself to new types of experiences based on the code. So I encourage you to do that. I hope you found that informational, inspirational, and remember, like we always said, go out there, have some fun, build some robots, and come back and see us.